we are here. We're going to talk about addition. So this is kind of your crash course PD in addition. So I want to talk about first the research. So when we say we want our kids to become fluent in addition within 20, which is the K2 standard, and then within 100, which is the second grade standard, we're going to focus on the K2 standard within 20. Kindergarten 5 to 5, first grade to 10, in most states, second grade to 20, although in some states it's first grade to 20. Fluency is efficiency, flexibility, and accuracy. Accuracy, knowing the right number and how to explain it. Flexibility, knowing lots of different ways to think about numbers. Efficiency, knowing strategies to use for the specific numbers that you have. Intentional, purposeful, meaningful practice with all of these things leads to automaticity, which means that children can answer questions within a reasonable amount of time. Technically, the research is 3 seconds, but it's pretty widely accepted that it doesn't have to be 3 seconds, but it should be a reasonable amount of time. The research. So the trajectory, you teach 1, then 0, because it's easier to add a quantity than it is a non-quantity. So you teach +1, then +0. And then you teach kids to add within 5. And then you teach kids to add within 10, starting to look at lower doubles, starting to look at neighbor numbers, and then, adding within 10, starting to look at pairs of 10. You start looking at adding 10 to a number, which is really easy for most kids. And then you start looking at bridging 10. And then you start looking at, you start looking at adding 10, then you start looking at doubles +1, doubles +2, and then bridging. And higher facts, 15 +4, 11 +8, and things like that. So there is a sequence, and you guys have the progression. You can get the progressions off of the site so that kids can follow where they are. So that parents and students and teachers and admin, everybody knows where everybody's going, because then you're much more likely to get there. This is the thing. There shouldn't be private data on public walls. So you want students to know where they are, and you want them to keep track of where they're going, but they should do that in their fluency binder. So every kid should have a fluency binder, and in that binder, it can have a bar graph, a line graph, or something to keep track of. This is what I know, and this is what I need to know next. So as visual goal setting, you can get all of that on the website. So that's the research, and then the sequence, and then the practice, the intentional practice. Should start with concrete materials, things like 10 frames. You say, I want you to show me 2 + 3. And now I want you to draw it out. And now I want you to show me the number sentence. So, you're going to take them through that cycle of concrete, pictorial, abstract. You're going to do lots of things. You're going to show them number lines and say, here is the model. What is the story? Oh, that's 1 + 1. And 1 + 1 is 2. Here's the model. What is the story? Show them a rec and rec model. And you say, ooh, what is that? That's 8 + 8. What is 8 + 8? It's 16. So, also we want to match models with abstract representations. So you're working on that cycle. You're going through that cycle of concrete, pictorial, abstract. You want kids acting things out. And that's why story mats are really important. And you will find those on this site, this example of story mat. And in the story mat, kids will pull a card, like the bakery had made 1 donut, and then they made 3 more. Right? The bakery made 1 donut, and then they made 3 more. How many did they make altogether? You want kids acting it out. Story mats are fun because they provide a realistic context. So kids get into it and they could see it. And like the cards we have on the site, they are supported by visual scaffolds as well. Concrete, pictorial, abstract, right? Well, we're going to act out this story. Then we're going to draw a picture. Then we're going to write the number sentence, right? Or we might just match the number sentence to the story. So really using and thinking about anchoring your unit of study in that cycle. Concrete, pictorial, abstract. It's not a hierarchy. They're in coordination with each other. You want the kids to see the connections of concrete, pictorial, abstract. Speaking of that, we give the kids, these flashcards. We have lots of flashcards. Flashcards that have the strategies. 8 plus 7 is a doubles plus 2. 5 plus 5 plus 2 more. 2 plus 4, that's a doubles plus 2 as well. It's 2 plus 2 plus 2 more. And then it shows the students 2 plus 2 plus 2 more. So there's flashcards that visually help. Here's another set of flashcards. These have the number line on them. And it's to remind students that when you're counting up, that you start with the larger number. So the equation is 1 plus 6, but there's a hint on the flashcard that says, remember to start with the big guy. You're going to start with the big number. So they have a number line so they can go to that 6 and hop up. We also have number line, not flashcards, that have the pictures. This is like pre-KK, right? Because remember, they're going to be using their fingers as their first friends. And then there's these really fun flashcards. These are all visual, notice. It has 3 dogs and 1 cat. So 3 plus 1 is how many animals? We have these working with property. Because remember, you're always trying to teach the property in relation to what you're doing, not as a sidebar lesson. Like one lesson on commutative property. What is that? You're doing commutative property and trying to make relationships throughout your unit. So we have these really great cards. So 0 plus 8, and then you flip it. And it's 8 plus 0, and then you check it. So working on properties. Looking at another property, we've got these great cards. Ooh, can you spot the doubles? It's one way to do it. What can we do here? There's a 10. Something we can add on. So looking at properties, ooh, there's a 10, and we can add on. That's a doubles. So there's a couple of ways to do it. How are you going to do it? It's really important to teach the properties and keep reinforcing them throughout, right? The identity property. What happens, right, when we do that? You want kids to understand what happens when I add 0 to a number. What happens when I add 1 to a number? What happens, this isn't a property, but what happens when I add 1, 2, or 3 as a strategy of counting on from the highest number? You're always having those discussions. So it's not about chasing answers, right? You're chasing thinking. You want kids to think. So I rarely say, what's the answer? I say, what's the strategy? So like if we throw a double dice, I got 6 plus 6, I wouldn't say, what's the answer? I'd say, what's the strategy? I want kids to tell me, oh, that's a doubles fact, right? And then I might ask them, well, if 6 plus 6 is 12, what's 6 plus 7? And how do you know? Or what's 6 plus 5? And how do you know? So it's really important to think about strategies and properties and visual scaffolds for understanding. Eventually you're going to phase all the visual clues out. But one of the things you'll have, like if you just have a regular flashcard, the first thing I would ask the kid is, what kind of fact is that? What kind of thinking are you going to do? What kind of fact is that? What kind of thinking are you going to do? And if you know that, then what? Then what else do you know? I mean, it's such a gift when we can give our kids that. And so I want you to think also about open questions when you're doing addition with your kids. You say the answer, the sum, because you want to use that vocabulary. The sum was 5. What were the add-ins? What was the question? What was the story? These are some really great cards too. This goes back to reasoning. So you give the kids these puzzle flashcards and this says like, ooh, 10 and 6 and 2 and 6. What is that? How can I balance this? And then they can turn and check. 6 plus 6 is equivalent to 10 plus 2. And so I want kids to think. It's part of the standards that kids can think about equations, that they're comfortable with equations. You want to give them opportunities to play games, puzzles, and things where they have to think about equations, where they have to think about equalities. You want them to do sorts so that they can think about, is this true or is this false? Right? So they're building that algebraic reasoning muscle. And so we have sorts on the website for students that actually do that. So I really think it's important to think about visual scaffolds, about the consistent teaching of properties and strategies, about using game boards that are strategic. So this is make 10, and it's missing number. And so they just have to go around the board and they have to make 10, but they're learning their complements. 7 plus what makes 10? How many more to make 10? Some kids will play this game and they'll use their fingers. Some kids will think about it mentally. Some kids will need a number line or a 10 frame, but they can all play. There's ways to level the playing field so that everybody can have access to the game. I would play this game in guided math groups. I would put this game in workstations, and I would send this game home for kids that are learning to make 10. I would say, dear parents, your child is working on making 10. Here's a board game, here's some flashcards. Please practice with your child on making 10 for the next week and write down what you all do. And here's another example of a game. This is a game where kids are doing somewhat what they were doing in the flashcards, looking at the numbers and deciding, is there an efficient way to add these? If I see 6 and 4 and 2, I know that 6 and 4 is 10 plus 2, or I know 2 and 4 is 6 plus 6. I want kids, as they're playing the game, they have to talk out the strategy that they're using. So again, more strategy practice with your board games. Individual practice. So children should set goals, and then they should set an action plan for achieving those goals. And I like visual goal setting. So we'll set goals with a little picture with the success criteria. What does it look like when you can do this? Your goal is to learn your doubles. What does it look like when you can do it? Well, you could solve doubles. You could come up with doubles. You could model doubles. You could solve double word problems. You could tell double word problems. You could explain doubles. When you really know doubles, those are the things you'll be able to do. So we know what the goal is, but what does the success criteria look like? And you need to give your students both of those to help them work towards goal setting. Workstation work, homework, and guided math work are all part of that action plan for goal setting. And you want to do quizzes. Now remember, in the Fact Fluency Academy for Intervention, there are the quizzes for all of the strategies right there that you can download. I don't believe a lot in time testing, but I do believe in like giving the kids a bunch of problems and just saying, circle the ones you know right away, just a check-in. Or giving the kids 2 colors and saying, oh, go. And then they fill out all the ones that they can in one color. Then I say, oh, switch. And then they fill out all the other ones. And then you get to know, like, which ones do they have automatically and which ones do they know they just don't have it automatically. So I call it a 2-color probe. That's one of the ways to get information you need. You get a lot more information that way, right? Because you get to see, well, who knows how to solve all their facts? They might not be automatic, but they know how to solve all their facts. Who knows all their facts and they're automatic? Who doesn't know any of their facts yet? And who knows some of their facts? So this idea of quizzes and ongoing assessment, very important. And you want to, be progress monitoring so that you know if where you're going is in the right direction. I would use also like beaded bracelets. I had another bracelet. Here's this one. This is a bracelet that goes to 10. So now kids can look at composing and decomposing. 1 and 9 make 10, 2 and 8 make 10, 3 and 7 make 10, 4 and 6 make 10, 5 and 5 make 10, etc. So I use a lot of these. And then when we get up to 20, we have just a beaded number line, but it's to 20. And you can make it in 2 colors. Some people make it in groups of 5. You should do whatever works for you. I like it in 2 colors often because then we can see that 10 and the rest. You want to have a lot of manipulatives. You want to have manipulatives you can send home. You know what I do? Sometimes this is old school. Now I'm totally dating myself. We take lima beans and spray paint them. Right. That was the math way, box it, bag it math kind of stuff, where you spray paint the pinto bean, the lima beans. Now you have 2 color counters and you get 10, you throw them, and then kids say, oh, I have 5 of this and 5 of that, or 4 of this and 6 of that, or whatever, and then they record. Because then you could send that home as a manipulative, because you're not going to send home your Unifix cues, but you'll send home some spray painted lima beans. The point is this: you want kids to do the math. They need to get their hands in it, right, and their minds in it, right? So concrete, pictorial, abstract, right? That cycle to build conceptual understanding along with procedural fluency. You want kids reasoning. You want them to have strategic competence, and you want them to be competent, capable mathematicians, right? So that's your crash course in addition. Thank you.